Hello, class. In this short video, I'd like to give you a tutorial on using Matlab online to plot and fit data that you took in Lab 2 using Tracker to record the motion of falling balls through different fluids like glycerol and water in order to plot the position of the balls as a function of time, and then to calculate their velocity. So let's take a look at the lab, and the that's lab 2. So go into latte and then scroll down to lab 2, and then if we open the lab, here it is. And so here's lab 2, analysis of motion and resistive forces. If you scroll down to the section on how to write up your results for the lab, then there's a link to a Matlab live script which you can download. So now I've updated this script to include a fitting function. So then if you click on this to download it, and then you go to your download file, then here you'll see it, plot and fit tractor data version 3. Now this has to be uploaded to Matlab online. So if we go to the Matlab online, so we open a new tab, type in Matlab online, start using Matlab online. So it comes up, and then it's, because I've already done this, it's brought up things. So let me just close this. You would have to go into, you'd come up with maybe a window like this, home, and then you'd have to upload, and then if you went to your download folder, then, this would be the file that you would upload, go open. And this target folder already has one or more folders with the same name. That's because I've uploaded it earlier, but let me just replace it. Okay, so now I go, okay, so now it's uploaded the version that was contained in the lab manual that was on Latte. And that's this thing, plot and fit tracker data v3. So now I'm going to open that by double clicking on it. Here it appears. And then, and so this is the window of the live script in Matlab. This over here has the variables. And just to start, I'm going to clear everything. So I'm going to go to view, the view tab up here, clear all output. And so it's cleared all the output over here. So now I go to my first, so it gives a little bit of text. This is to be used in conjunction with two folders, two files that have the data taken from Tracker of the large ball falling in glycerol and a small ball falling in glycerol. So those are the two data files, which also need to be uploaded into Matlab. So steel large and the medium metal glycerol are the two text files that also need to be, these ones here that need to be uploaded. Okay, and so then last time I had a video which taught you how to plot the data. So to plot the data, you have to read in the data. So if we go to live editor, if we go run section with the cursor in this section, then here's the table with the time in seconds and the position of the ball as in centimeters. Okay, and then, this I covered last time, so it's in the previous video. I'm just gonna go through it quickly here. So here I read in the data as arrays, the time and the space, the time of the ball falling, the position of the ball falling, and then I just plot time versus position, and I get this line of the position versus time. Nothing's labeled, so it's not a proper plot. And my time is not a time t equals 0, but it's the time at which, in the video that the ball was recorded. And so I want to move all my times to 0. So I subtract off the time of the first recording value from all the subsequent recording values. And since time increases linearly, then I can set my initial time to 0. I'm just resetting the time, and then I plot it with a blue line with symbols. So that's what's going to be done here. So I run the section, and so here I have my actual data points and then a line drawn connecting the data points. But still, there's no labels on the axes. So down here, I show you how to add labels to the axes, and here's a legend, large steel ball and glycerol. It's got the height in centimeters, time in seconds. It's offset, so now it starts at, we remove the offset, it starts at 0. I don't like these circles with a line going through it. I think that is ugly. So then I wrote a little piece of code here that fills in the circles with a white background. So now it's more pretty. So here's a nice pretty plot. And then here's code in Matlab to show you how to plot two together. And I went over this in detail in the prior video. And so then here we have height versus time. They're labeled with a legend. Green is the medium steel ball, and it takes longer to fall the same distance than the larger ball. So the larger ball falls faster than the small ball. And this is where we left off last time. We plotted two plots as a function of time. Okay, so now we're going to fit it to a straight line. So we're going to say that the height is equal to some slope times time. It's going to just be linear in time with a offset. So time t equals 0, the ball might not be at position equals 0, but somewhere a little bit off. So we're going to fit this data to a straight line. So how is that done in Matlab? So here, I'm just going to start over again, where instead of plotting two curves, I'm just going to plot one curve. So here's the code. Read the data for the large sphere. The large sphere is this one, the one that falls fast. Plot it and label it. So that's what I'm going to do with this. That's what I'm going to do with this guy here. Okay, so let's run that section and plot the data. So here is just the raw data. It's got the raw data and then line connecting the raw data points. And if I want to get rid of the line connecting the raw data points, I could just, that's this dash here. So if I remove that dash, now it's just blue circle telling it to make a blue circle. So now if I replot this, run the section, then now it's just the data points, because I removed the telling it to plot in blue both the align, connect, and the symbols. So here I'm just showing the symbols where the actual measurements. Okay, so now we're going to fit and plot a straight line fit, a linear fit on the same figure. So the function in Matlab is called polyfit, and it's got to fit a polynomial of degree 1. Degree 1 means it's just going to be y equals mx plus b. If it was degree 2, it'd be y equals like ax squared plus bx plus c. So, but we're not going to fit it to a second order polynomial. We're going to fit it to a first order polynomial. That means just linear in time. Okay, so we have our time coordinates t1, and we have our space coordinates, the positions of the ball, y1, and then this 1 tells it just fit a straight line. And then this returns an array, P. The first value of P is the slope, so P1 is the slope of the fitted line, and P2 is the intercept. And then once so then we can calculate the fit by, since the formula is y equals mt plus b, if we know the times, we have the slope and the b, we can generate the fitted function. So then, polyval is the function, it generates whatever polynomial polyfit creates. So P then contains the slope and the intercept. And so if I give it the slope and the intercept, this slope and this intercept, and I give it the values that I want to calculate the fit, there's the values of time, so T1, then it will generate the fitted data, Y fit. Okay, and so then I tell Matlab, hold on, keep this same. Hold on means I'm going to plot the fitted result in this same frame without rewriting the height or the labels or the symbols. And then I'm going to plot T1, the time, and then my fitted data. And I'm going to plot that with a red line. R dash means a red line. And then I'm going to put in a legend. And so let's see if this works. So I run the section. So now, so here was the raw data. And so now I plot in the same window, I plot the fitted, data, and it looks like I did things in the wrong order. Yeah, the first one is not the fitted, the first one is the experimental data. And so this is the experimental data was the first thing I plotted up here. And then the second thing that I plotted is the fitted data down here. So I don't know what happens if I run that again. Yeah, so now the experimental data is this blue, and then the fitted data is the red. And so that's how, and then the slope of that line is minus 57. So in 1 second, the thing will have fallen 57 centimeters. So in a half a second, it will have fallen about 28, 29 centimeters. And that looks about right because it starts, here at minus 1.7 around 2, falls to around 28. So it looks like it falls around 26 in the first half second. So that's going to be like 50 something in the first second. So this slope looks correct to me. So that's the slope of this line, rise over run. So the rise is approximately 30 in half a second. So that would be 60 in a full second. So the rise over run is 57, and the intercept at time t equals 0, the intercept is minus 1.7, which looks correct on this plot. So this is the code of how you could fit. And now if you want to plot and fit straight lines to both sets of data, then this is the code to do it. So let's run this code. And this is the plot it generates. So let's walk through it. Let's walk through it. So here we run a polyfit on the first data set, T1 and Y1 is the time and space from the large ball, read from the large glycerol, large steel ball file, while T2, Y2 is the data from the medium-sized metal steel ball in glycerol. So we first fit to T1 and Y1 and calculate the fit. That's what these lines are here. So this does the fit, returns the parameters, the slope and the intercept, and then using the slope and the intercept, we calculate the fitted values. And then we plot those. So that's what the R is. And we hold on, so that means we're going to keep it in the same frame. Then now we plot the raw data, T1, Y1, and we're going to do that with a blue, data, which has a line connecting to it, but that line's a little confusing, so I'm going to get rid of that line. So now it's just going to be blue circle. So then I plot that. So now the red, what all you see here is the red line, the fitted line, and the raw data. So that's here. And then I put in the labeling, height, time, height versus time, make it look more, so we can understand what's going on. Now I fit to the second set of data, which was the medium sized steel ball, get its slope and intercept, generate the fitted to the medium, and then I plot that as a blue line, and then I plot the raw data green with a line through it. But let's get rid of the green line again. Just plot the circles, and then the line is kind of held back underneath it, so it's mainly obscured. If I wanted to see that fitted line, I could, instead of having marker face white and marker size 8, I could just get rid of this. So I could just, let me copy this line. So I copy this line and I paste it here. And I'm going to comment out this line, this symbol, this percent sign copies out the code. And now if I can just get rid of this marker size stuff, I mean this marker, I'll keep the marker size, but I'm not going to give it a color. I'm not going to fill it with white. So now it's not filled. And so then I run this section. So then the line just goes over the data. The data is not painted with white. It's just the circle. So I can see it better. So there's my fitted one. And I could do the same. I could do the same here if I wanted to get rid of the, where did I plot? That's probably that's up here, right? That's where I plotted the first set of data. So again, if I copy this line, and then I just comment out the first. Then if I get rid of the fact that it's filled with white, so now I'm just setting my marker size, but I'm not coloring it in with a white interior. And so if I now run it, then I see my red fitted line going through the data, my blue fitted line going through the data. And so those are my fits. And then these are the values written down here. M1 is the slope for the first line, first data, which is the, which is here, the steel, the big steel ball. So that's here, experimental data, large steel ball, red. So fitted data, the large steel ball, that's this one. And then M2, B2 is much smaller slope, and that's experimental data from the medium steel ball. Now, if I want to plot this data, I can click on this, and then if I mouse over here, there's this icon that comes up with a kind of floppy disk save, save as. So I click save as, and then I have to save it somewhere around here. I'll call it my first Matlab plot. And now the save is grayed out. So I go Matlab drive, published, my site. I'm gonna put it here. So I go now save as a PNG. And then if I go to home, I can go, I think, download. So I have to see publish. Okay, here it was publish my. So if I click on my first I went to publish my site, my first MATLAB plot. I go download, and my first MATLAB plot is here in my downloads domain. Double click on it, and voila, this is something you can include in your lab report, and all proper. Okay, so that's a introduction to plotting multiple data sets and fitting them to straight lines in MATLAB with some decent looking plots that you can include in your report. That's all for now. Talk to you later. Bye. Stop the share and then stop the recording.